When you see a massive cement mixer, you probably just think of brute force and diesel fumes, right? Well, today, we're going to pull back the curtain and show you the incredibly complex digital brain that's actually running the whole show. We're breaking down the software that controls a hybrid cement mixer to build a complete blueprint for how these amazing systems are made. So first things first, this is not your average truck. We're talking about a 40-ton hybrid that has to perfectly balance a high-voltage battery system with a massive diesel engine. It needs raw power for the highway, but also the precision of a surgeon on the job site. It's a huge balancing act. So that brings us to the big question, right? How in the world do you manage all that? The answer is a powerful little computer called the Vehicle Control Unit, or VCU. But really, it's all about the software, a super carefully planned, safety-obsessed architecture that acts as the truck's central nervous system. To build software this important, you can't just jump in and start writing code. No way! Just like building a skyscraper, you have to start with a rock-solid blueprint. This first stage is all about laying that digital foundation, so everything that comes later is built on solid ground. And that foundation has a name: AUTOSAR. The easiest way to think about it is like Windows or iOS, but for a vehicle's brain. It's a standard operating system that organizes all the software into separate layers. And this is absolutely key, not just for keeping things organized, but for safety and for building code that you can reuse on other vehicles down the line. So AUTOSAR works in these three main layers. Up top, you've got the application layer. That's the thinking part, the actual control logic. Way down at the bottom is the basic software, which talks directly to the nuts and bolts, the hardware. But the real magic is that middle layer, the runtime environment. Think of it as a nervous system that completely separates the brain from the body. This lets them talk to each other safely and super efficiently without getting in each other's way. Now, this VCU's brain isn't just one processor. It's multi-core, just like your computer. And the tasks are split up very cleverly. Core 0 is the boss. It handles all the critical, split-second safety and control stuff. Core 1 is the communications expert, handling all the diagnostics and network traffic. And by putting that on a separate core, all that chatter can't interrupt the important safety calculations. Finally, Core 2 is the strategist, handling the slower, long-term energy and temperature management. It's a perfect division of labor.
Okay, so the foundation is in place. Now we get to build the heart of the system, the core engine. This is the software that actually controls the truck's every move, managing that complex dance between the diesel engine and the electric motor.
So every single time the driver even thinks about touching the accelerator, it kicks off this whole chain reaction. The VCU doesn't just blindly follow orders. First, it listens for commands from other systems, like stability control, which might need to cut power to stop a skid. Then it figures out the best mix of electric and diesel power, checks for any safety limits, and only then does it send the final, perfected command to get the wheels turning. And this is the key takeaway. Not all commands are created equal. This pyramid shows the pecking order perfectly. At the very top, with total authority, are the safety systems. If the stability control freaks out, its commands will override everything, even what the driver is doing. In this system, safety always gets the final word. Okay, you know that feeling, right? When your car kind of lurches or shudders when it shifts gears. In a normal car, that's just annoying. But in a 40-ton truck full of sloshing concrete, that kind of shock is not just uncomfortable, it can actually damage the vehicle over time. And this is where the hybrid system is just brilliant. The VCU has something called an anti-jerk strategy. See, the electric motor can react in milliseconds, way faster than the diesel engine. So it actually creates these tiny opposite bursts of torque that cancel out the vibrations before you can even feel them. It's literally acting like a digital shock absorber, making the whole ride incredibly smooth. All right, so we've covered how the truck drives. Now let's get to its real job, being a cement mixer. This is where the software gets tailored for the very specific, very demanding tasks that this machine was born to do. The number one challenge is that drum. You see, the concrete has to be churned at a very precise, constant speed to stay perfect. So the electric power takeoff, or ePTO, lets the drum spin completely independently of what the truck's engine is doing. But here's the really smart part. What if the truck is just sitting on a job site for hours and the battery starts to run low? Well, the VCU is smart enough to just automatically fire up the diesel engine, not to move, but to act as a generator to power the drum and top off the battery. How cool is that? Okay, now we get to what is, without a doubt, the most important part of this entire design: the safety shield. In a machine with this much power and high voltage electricity, safety isn't just a nice to have.
It is the absolute non-negotiable foundation of everything. It's all built to a super strict automotive safety standard called ISO 26262. So to guarantee this thing is safe, the software has a 3-level safety net. Level 1 is the normal software that does the calculations, but it's considered untrusted. So level 2 is like a supervisor, running a separate, simpler calculation to constantly double-check level 1's work. If they disagree, level 2 shuts it down. And then, as the ultimate fail-safe, level 3 is a hardware guardian, a watchdog chip that literally watches the processor. If it senses anything's wrong, it can physically pull the plug. And this is what all that safety tech actually prevents. Let's make it real. What if a pedal sensor fails and tells the truck to go full throttle? The system instantly detects that that's not plausible and goes into a safe state. In this case, a total torque cut, 0 power. Or picture a worker cleaning the chute when the drum starts to turn. Nope, the system's goal is to prevent that, locking the motor to keep that worker safe. Every possible disaster has a pre-planned, safe escape route. So, the code is written, the safety systems are designed. Time to hit the road? Not even close. Now comes the grand finale of the development process, putting the software through a virtual trial by fire to prove it can handle anything. Before this VCU gets anywhere near an actual 40-ton truck, it gets plugged into a massive simulator. It's a process called hardware-in-the-loop testing. Basically, the real VCU is tricked into thinking it's driving a real truck in a virtual world. This lets engineers throw every insane failure scenario they can dream of at it safely and over again. Okay, let's run through some of these virtual nightmares. Test 1. Picture a fully loaded truck trying to start on a super steep hill. At that exact moment, the engineers virtually cut the communication wire to the motor. What has to happen? The VCU has to detect that signal loss instantly and slam on the parking brake to prevent a terrifying rollback.
Test 2, the truck is now cruising down the highway, and someone hits the big red emergency stop button. The VCU can't just kill everything. That would be dangerous in itself. It has to follow a precise, orderly shutdown sequence. Kill the engine, disengage the motor, and safely power down the entire high-voltage system, all while the truck is still rolling. And for the last one, this test is sneaky. The accelerator pedal doesn't completely fail. It just starts to drift, sending signals that are slightly off. That level 2 safety monitor has to spot this subtle error, flag it, and gently put the truck into a limp home mode, slashing the power but giving the driver just enough control to pull over safely. And this quote from the lead architect really says it all. See, they weren't just building software for one truck. By using a standard backbone like AUTOSAR and having a relentless focus on safety, they were actually creating a blueprint, a reusable, expandable control platform for the entire future of heavy-duty hybrid vehicles. So the next time you're driving and see one of these massive mixers, maybe you'll see it a little differently. Not just as a big, loud machine, but as a finely tuned hybrid system, all guided by an invisible, multi-core brain, running thousands and thousands of lines of code to make sure every single moment is powerful, efficient, and, above all else, incredibly safe.